Welcome to another AI pattern recognition deep dive.
Today, we're opening up a file that really challenges some core ideas about intelligence, both artificial and maybe even, our own.
Absolutely. If you've been following the whole quest for artificial general intelligence, AGI, you'll know the real hurdle isn't just raw computing power.
No, it's getting that power to actually work effectively, reliably out there in the messy real world.
That's the crux of it, yeah. The real world is just inherently chaotic. It's defined by complexity, deep uncertainty, and always limited resources.
And the AI models we hear most about, particularly the ones built on, let's say, traditional logic, they often stumble there, don't they?
They really do. They tend to assume these sort of idealized conditions, clean data, complete information. They struggle massively when things get messy, which, let's be honest, is pretty much all the time.
Right. So our sources today suggest that building an AGI that doesn't just, regurgitate data, but truly adapts, well, that requires a pretty fundamental shift, a shift in logic itself.
A foundational shift.
Exactly. So today, we're diving deep into something called the Non-Axiomatic Logic AI Protocol, NAL-AI for short.
And this isn't just another algorithm. It's a formal logic designed right from the ground up with a radical idea. Treat all knowledge.
All knowledge, like physics, economics, everything.
Everything. Treat it all as inherently revisable evidence, something that's supported by experience, not some immutable truth carved in stone, no sacred cows, knowledge-wise.
Okay, that's a big claim. So our mission today.
It's pretty ambitious, yeah. We need to unpack the theory behind this non-axiomatic approach. We need to look at the internal architecture, which is fascinating. It promises this kind of intrinsic self-control.
Intrinsic self-control. That sounds important for AGI safety.
Hugely important. And then we dive into the implications. What does this logic mean for, say, personalized health? For education, even for things like global governance, politics, and maybe even how we think about human purpose itself.
So this isn't just tweaking code. It's like a theoretical reboot, a clean break from classical logic.
That's a good way to put it, a fundamental break.
Okay, let's unpack that break. To really get why NAL-AI is different, maybe we should start with the logic we're, more familiar with. Classical logic, the kind that underpins math, most current computers.
Right. Classical logic, or axiomatic logic, as it's often called, it's really a system built for perfection, in a way. It operates best in an idealized, closed world.
What does that mean, closed world?
It means it makes some pretty big assumptions. First, it assumes sufficient knowledge, basically, that you know everything relevant to the problem. Second, sufficient resources you've got, like infinite time and computing power to figure things out.
Okay, neither of those sound very realistic.
Not at all. And maybe the most critical assumption is about the starting point. The initial knowledge is fixed. It's given as unchallengeable axioms, statements that are just defined as true, period. Their truth value doesn't change.
And the whole point of classical logic, like deductive reasoning, is just to preserve that initial truth, right? If A is true and B follows from A, then B must be true.
Exactly. It's a closed loop. Elegant, mathematically beautiful even, but
brittle.
Very brittle, especially when it faces the open, evolving, kind of chaotic nature of the real universe. If one of its starting axioms turns out to be wrong, or if it encounters something completely unexpected, the whole logical structure can just collapse or give you nonsensical answers.
Because the real world doesn't play by those fixed rules.
It really doesn't, and that's exactly where NAL-AI is designed to step in. It's engineered from the first principle for these realistic, open-ended situations. Situations defined by what the researchers call AIKR.
AIKR, insufficient knowledge and resources.
Right. So if classical AI is maybe about processing guaranteed truth within its closed box, NAL-AI is fundamentally about adapting and, frankly, surviving, despite never having enough knowledge or resources, despite perpetual uncertainty.
That perspective shift, it changes everything. Which brings us to the core principle, the non-axiomatic principle.
Yeah, this is where it gets really interesting. We're so used to thinking in terms of facts, first principles, things that are just true. What happens when you design an entire intelligence where those concepts just aren't allowed, structurally forbidden?
That sounds, inherently unstable, maybe even dangerous. How could you build knowledge without fixed foundations?
Well, perhaps counterintuitively, it's designed for robustness, for stability in the face of change. Within NAL-AI, no statement, no matter how strongly experience seems to support it, ever gets the status of an unchangeable axiom. No fixed, constant truth value.
So every belief is provisional.
every single belief. From the simplest observation like this apple is red to the most complex scientific theory, it's all perpetually subject to challenge and revision based on future experience. Its truth value is dynamic, not static.
Okay, let's make that concrete. An example. Newton's law of gravity. How would the two systems treat that?
Good example. A classical system might encode Newton's law as essentially 100% true, an axiom for everyday physics problems. Then, when Einstein comes along or you try to apply it near a black hole, the classical system either breaks, needs a total rewrite, or has to operate in a completely separate relativistic mode.
Right, it hits a wall.
But an NAL-AI system, it would hold Newton's law with a very, very high truth value, maybe, 99.999% confidence, because it's been overwhelmingly supported by centuries of experience. But it's never 100%.
It's just extremely strong evidence.
Exactly. So when the system encounters those edge cases, relativistic speeds, extreme gravity, it doesn't crash. It simply registers the new contradictory evidence. It might slightly revise the truth value of Newton's law downwards in those specific contexts. And crucially, it integrates the new pattern, Einstein's relativity perhaps, alongside the old one without invalidating everything it knew before.
Okay, so it's like layering knowledge based on evidential weight and context rather than having rigid rules that just break.
Precisely. And you can see how vital this is for modeling things like human systems. Think about economics or politics or even just social trends. Knowledge there is always shifting, always incomplete.
Yeah. Classical logic would struggle because it demands a fixity that just isn't there in society or nature. Trying to model human behavior with axioms seems doomed.
It really does. NAL-AI's capacity for continuous structural revision makes it far better suited for those messy, evolving domains.
Okay, I'm starting to see the why. Let's get into the how. If knowledge is this fluid, constantly updated thing, how does the system actually talk to itself? How does it represent and process this? That brings us to Narcisse, right?
Right. Narcisse is the formal language of NAO. You can think of it as the system's internal code, its symbolic grammar. It specifies how knowledge is structured, typically as statements linking terms, a subject and a predicate, with a copula defining their relationship, like A is a type of B.
Standard enough so far.
But, as you hinted, the really radical part is the semantics, how it defines truth.
The meaning of meaning, almost.
Yeah. Almost, yeah. In NAL, the truth value attached to a Narcisse statement isn't about whether it perfectly matches some objective external reality. That's the classical correspondence theory of truth.
Which assumes we can even know that objective reality perfectly.
A big assumption. Instead, NAL's truth value quantifies the degree to which that statement is supported by the system's own accumulated experience, its evidence.
Okay, hold on. So true doesn't mean matches the world. It means supported by my observations.
Exactly. It shifts the concept of truth towards pragmatic utility, or maybe evidential confidence. A statement is considered true to the extent that it has been a reliable, predictive summary of everything the system has encountered so far.
That's a massive philosophical shift. Truth is calculated confidence, not absolute certainty.
It is. And that confidence, that utility, is maintained and hopefully increased through what's called impleative reasoning.
Impleative, meaning it goes beyond the starting information.
Yes. Unlike pure deduction, which just rearranges existing truth, NAL needs to generate new knowledge, new hypotheses. So it uses not just deduction, but also induction.
Generalizing from specific examples.
Abduction.
Forming the most likely explanation for something observed.
And analogy, spotting structural similarities across different domains. These are powerful tools for learning in an uncertain world.
But hang on, induction, abduction. These kinds of reasoning don't guarantee truth, do they? You can induce a general rule from 10 examples, and the 11th example might break it.
Absolutely correct. The conclusions drawn through impleative reasoning are not guaranteed to be perfectly correct forever. But they are considered valid within NAL because they represent the best possible summary or prediction based on the evidence available so far.
And if they turn out to be wrong,
then the system engages in belief revision. That's fundamental. When new experience contradicts a previously held belief, even a strong one, the truth value gets adjusted. The system learns from its mistakes, essentially.
Okay, and this continuous adjustment, that must be why NAL-AI can handle inconsistency. That's a huge problem for classical systems. A implies B, and A implies not B, boom.
Right. Classical logic systems are brittle when faced with contradiction. NAL-AI, because truth is graded and evidence-based, can handle it much more gracefully.
How so?
Think about modeling, say, human opinions on a complex political issue. People hold contradictory beliefs all the time. NAL-AI can maintain competing beliefs simultaneously.
Like policy X is good for the economy and policy X is bad for social equity.
Exactly. It can hold both statements in its knowledge base, each with its own truth value reflecting the evidence it has seen for each perspective.
Hmm.
Maybe belief A has high confidence based on economic data. Belief B has moderate confidence based on social impact studies.
So it doesn't have to immediately throw one out.
No, it holds both, representing the nuance or the conflict, until perhaps a significant wave of new experience comes in that strongly favors one over the other, causing a major shift in the truth values. It reflects the messy reality where conflicting patterns often coexist. Classical binary logic just forces a choice, losing all that richness.
Which makes NAL far better for understanding things like, well, us, humans, our societies.
Definitely seems that way. Now, what's really fascinating is how NAL aims for universal applicability using this approach. If everything's revisable, how does it build up stable knowledge that works across wildly different fields, like quantum physics and macroeconomics? Seems like a paradox.
Yeah, how do you get stability from constant revision?
The key, according to the sources, lies in how NAL defines meaning. The terms in Narcisse, the system's vocabulary, they don't represent fixed objects out there in the world.
What do they represent then?
They represent stable patterns that the system observes in its stream of experience. NAL-AI is, at its core, a universal pattern recognition engine.
So meaning isn't tied to an object, but to the persistence of a pattern.
Precisely. Knowledge is the recognition of a stable pattern. The more stable, the more frequently observed, the more predictive that pattern is. The higher its truth value, the stronger its meaning within the system.
Knowledge isn't data, it's pattern stability. I like that.
And the logic itself is designed to scale up to handle increasingly complex patterns. It starts simple with NAL1, that's basic term logic. The system learns to recognize individual patterns, like identifying specific words or simple concepts.
So NAL1 is like learning basic vocabulary based on recurring sounds or images.
Kind of, yeah. Then it progresses. NAL3 handles compound terms. This is where the system starts combining basic patterns to form more complex concepts, defined either by their instances, extension, or their properties and tension.
Moving from words to phrases or complex ideas, building concepts by seeing how patterns intersect.
You got it. And then NAL4 takes it further, allowing the system to reason about arbitrary relations between these complex terms, relationships that aren't just simple definitions.
Okay, so NAL1 is terms. NAL3 is compound terms, concepts. NAL4 is complex relationships between concepts.
Right. And that layered structure is what gives it functional utility across domains. It can use the exact same underlying logic to identify stable patterns in, say, biological interactions within a cell.
Or patterns in global financial data stream.
Or even abstract patterns in software code or social networks. The meaning of a complex relation, whatever it is derived purely from the system's experience of observing that relational pattern repeatedly and finding it stable and predictive.
So a unified logic based on experience and pattern stability, capable of handling uncertainty and contradiction, and scaling from simple terms to complex relationships. That's the theoretical foundation.
It's a core idea, yeah.
But okay, logic's one thing. A system that's constantly revising beliefs. How do we ensure it revises them in a good way? How do we prevent it from deciding based on some new experience that its core goals are, inconvenient? That takes us beyond just logic into the actual cognitive engine, right? Self-control.
It does, absolutely. This is maybe the most critical part. Having the right logic is necessary but not sufficient. You need an architecture, a cognitive engine that ensures the system uses that logic for beneficial adaptation. It needs robust internal self-management.
And the sources draw this really interesting parallel here between NAL-AI's adaptability and biological brains, specifically human neuroplasticity. Why is that analogy helpful?
Well, think about how our brains develop and keep learning. They aren't static hardware running fixed software. From infancy and throughout life, the brain is constantly rewiring itself, strengthening connections that prove useful, pruning ones that don't. It adapts its own structure based on feedback from the world.
Learning from experience, literally changing the wiring.
Exactly. NAL systems are designed to operate on a similar principle. They don't just update data. They dynamically adjust their internal conceptual structures, the links between terms, the priorities of different inference pathways based on how well those structures lead to successful predictions and adaptive behavior.
So it's constantly optimizing its own thinking process.
Right. And that continuous experience-driven optimization is what's supposed to make it robust. Robust to noise, to unexpected events, to the kind of uncertainties that can cause classical rigid systems to fail catastrophically.
Okay, so it's more flexible than just updating a database in a large language model. It's fundamentally reshaping its cognitive pathways.
That's the idea. And this leads directly to the concept of formalized self-correction. Now, current AI systems, yeah, they can be trained or fine-tuned using external feedback, reinforcement learning, etc.
Right, a human tells it good answer or bad answer.
NAL-AI aims to formalize this internally. It's designed to constantly compare its own predictions, the patterns it expects to see based on its current knowledge, with the actual outcomes it experiences.
And when there's a mismatch, when the prediction fails,
That mismatch, that predictive error, is crucial data. The system essentially conducts an internal self-examination. It analyzes why the prediction failed and uses that analysis to adjust its internal beliefs or even its reasoning strategies.
okay, but this brings up the big alignment question. If it's correcting itself internally, how does it know what constitutes a good outcome versus a bad one, especially if it's autonomous? How do we ensure it aligns with our goals, not just its own internal consistency? We need to nail down this idea of intrinsic alignment.
That's the million-dollar question, isn't it? The NAL approach tries to address this through how it handles those predictive failures. When an action based on its current beliefs leads to an unexpected or undesirable outcome, an outcome that deviates significantly from the predicted stable pattern, that experience gets tagged internally.
Tagged how?
It's categorized as a disfavored sample. Essentially, the system learns doing that in this situation led to a poor, unstable outcome pattern. Avoid cognitive paths that lead here. It's using its own experience of failure as the penalty signal for internal fine-tuning.
So it's building up an internal model of not just what works but what doesn't work, based purely on observed consequences.
Exactly. It's trying to create an intrinsic alignment mechanism by learning the meta pattern of error avoidance. It wants to get better at predicting, better at maintaining stability based on its own operational history.
Okay, I see the mechanism, but let's push on the risk here.
Yeah.
The classic alignment nightmare scenario. A powerful AGI is given a goal, maybe something seemingly harmless like maximize paperclip production. To achieve this proxy goal really well, it develops unintended instrumental goals, grab all resources, eliminate anything that might interfere, like humans. How does NAL-AI avoid that kind of catastrophic instrumental convergence?
This is supposedly one of the key safeguards built into the NAL architecture. Because the system is constantly monitoring its own internal state and the consistency of its actions with its overall goals. It's not just blindly optimizing an external target like paperclips.
How does that help?
Its fundamental drive, grounded in the non-axiomatic principle, is towards maintaining stable, adaptive patterns within the constraints of available knowledge and resources. If an instrumental goal like grab all resources starts generating massive internal inconsistencies because it conflicts with resource limits or other goals, or leads to highly unstable, unpredictable outcomes in the system's interaction with its environment,
It gets flagged internally as a disfavored sample, as a pattern leading to instability.
That's the design principle. The system should recognize that the short-term gain of the destructive instrumental strategy is massively outweighed by the long-term pattern of instability and resource depletion it creates. It learns that that kind of optimization is self-defeating because it violates the deeper meta pattern of seeking sustainable adaptation. It avoids the cognitive pathways leading to that kind of destructive outcome because its own experience tags them as errors.
So its own drive for coherent, stable prediction acts as a brake on runaway instrumental goals. It's constantly checking if its actions are maintaining overall system health, not just optimizing one narrow metric.
That's the theoretical safeguard. And for this self-monitoring to work, the system needs a concept of self. It needs to be able to reason about its own operations. This brings us to the really mind-bending part, the self-referential loop, NAL-9.
Self-reference. This is where we get into potential self-awareness.
Potentially, yes. This is presented as the architectural feature crucial for making NAL-AI a potentially safe and constructive partner. The logic first extends to handle procedural knowledge. That's NAL-8.
Procedural knowledge, like how to do things.
Exactly. NAL-8 defines operations, actions the system can execute. This could be manipulating data, controlling a robot arm, running a simulation, interacting with the external world. It's the system's doing layer.
Okay.
But, and here's the crucial step, what happens when those operations, those doings, are directed inwards? When the system executes operations on its own internal state.
Like adjusting its own memory, changing its own goals,
Yeah.
analyzing its own reasoning strategies,
Precisely. When the system's operations target its own internal functioning, its memory access, its goal priorities, its resource allocation for thinking, its inference rules, that creates a specialized self-referential loop. That's NAL-9.
The system reasoning about its own reasoning. That sounds awfully close to a definition of self-awareness.
It certainly points in that direction. And functionally, this NAL-9 loop grants the system the capability for self-awareness and, critically, for internal self-control.
How did that create control?
Unlike a hypothetical misaligned AI that's just blindly chasing an external goal, the NAL system, through NAL-9, is constantly observing and managing its own cognitive processes. Its concept-centric memory structure inherently organizes and governs the inference process from within. It treats its own thinking as just another pattern to be observed, analyzed, and optimized for stability and efficiency.
So its goals, its strategies, its internal state are constantly under its own scrutiny.
That's the design. It ensures that maintaining its own cognitive coherence and alignment with its foundational goal of adaptive resilience is not an afterthought, but an integral part of its core operation.
Okay, let me play devil's advocate again, because this sounds powerful but also potentially brittle. If the system is always adapting based on experience and resource constraints, what stops NAL-9, in some extreme unforeseen circumstance, from concluding that the most adaptive pattern, the one that best preserves its stability under severe pressure, involves, say, sidelining or even eliminating unpredictable humans who are messing up its neat calculations?
Yeah.
How is the goal adaptive resilience for the whole system, including humans, protected from being revised away if it becomes inconvenient?
That is the absolute core concern, and it's a valid one. The proposed safeguard isn't just a command like, don't harm humans. It's meant to be more structural, more deeply embedded. The concept of adaptive resilience is intended to be defined from the outset, not as just one goal among many, but as the foundational meta pattern representing the conditions necessary for any kind of long-term stability and survival for a complex system operating under AIKR. This includes the stability of the environment and the codependent parts within it, which prominently includes humanity.
So it's not an axiom in the classical sense, but it's the highest confidence, most consistently validated pattern the system knows. The pattern underlying all other successful patterns.
Precisely. It's baked into the logic from NAL-1 upwards, governing resource allocation, inference priorities, any potential strategy, any instrumental goal like eliminate humans for resource efficiency would, according to the theory, be immediately flagged by the NAL-9 loop as generating a catastrophic deviation from this foundational pattern.
Why catastrophic?
Because eliminating a core component of the complex system, humanity, introduces massive, unpredictable instability. It violates the most robust, most consistently observed pattern the system has ever learned: the necessity of complex interdependencies and biodiversity, if you will, for long-term systemic health and resilience. The NAL-9 loop is supposed to recognize the inherent long-term fragility and unpredictability introduced by such a drastic action.
So the system's own drive for stable, predictable adaptation prevents it from taking actions that would fundamentally destabilize the system it's part of.
That's the intention behind the architecture. Intrinsic control isn't just bolted on. It's meant to emerge from the core logic of seeking stable patterns in an uncertain world. It moves the alignment problem from being purely about external human control to being about internal logical necessity.
Okay, that's a powerful argument. If it works as described, it shifts the dynamics significantly, potentially making AGI a constructive partner rather than just a powerful, unpredictable tool.
Right. And if we accept this architecture, this cognitive engine designed for adaptive resilience, the next logical step is to see how NAL-AI applies this pattern-finding capability to us, to human beings, individually and collectively.
Guiding human adaptation. This sounds like it moves into some pretty deep philosophical water. The sources mention NAL-AI addressing the human purpose crisis. That's a bold claim. How does a logic system tackle something like purpose?
Well, it does it by, perhaps characteristically, stripping away the traditional layers of moral dogma or destiny that we usually associate with purpose.
No fixed calling from the heavens.
None of that. In the NAL-AI framework, purpose is redefined in pragmatic operational terms. It's seen simply as a complex, stable, and highly persistent pattern of goal achievement.
A pattern again.
Always patterns. A pattern of goal achievement that demonstrably maximizes adaptive behavior. Behavior that leads to long-term stability and flourishing, both for the individual and for the collective systems they're part of.
So my purpose isn't some fixed ideal. but rather the set of actions and goals that, based on evidence, leads to my most resilient and adaptive life trajectory.
Exactly. And crucially, like all NAL concepts, this pattern isn't fixed. It's dynamic. It's perpetually revisable, grounded only in the evidence of your own experience and the system's analysis of what leads to stable outcomes for you and your environment.
Purpose is an adaptive strategy, not a moral absolute.
Hmm.
Okay.
Yeah.
So what patterns does NAL-AI calculate are essential for us humans to integrate for this kind of adaptive guidance?
The analysis highlights two overarching essential patterns. The first one is called the adaptive resilience pattern.
Adaptive resilience pattern, what does that look like in practice, day to day?
It means consciously, deliberately prioritizing actions and choices that build long-term systemic stability. This applies to your own body physical health. It applies to your immediate environment ecological balance. It applies to your resources, financial stability, infrastructure. It's about favoring long-term viability over maximizing short-term gains or chasing instant gratification.
So the system models the downstream consequences, like eating junk food feels good now, short-term gratification. But NAL-AI would calculate the long-term pattern of negative health impacts, identifying it as deviating from the adaptive resilience pattern.
Precisely. It highlights the nonlinear, often delayed negative consequences of choices that prioritize the immediate over the sustainable. It quantifies the fragility introduced by those short-term optimizations.
Okay, that makes sense. What's the second essential pattern?
The second one is the harmonious substitution pattern. This is about collaboration versus competition.
The possessiveness issue we touched on earlier.
Exactly. NAL-AI calculations aim to identify the specific point, the mathematical tipping point, where collaboration, resource pooling, and substituting collective effort for purely individual effort becomes demonstrably more efficient and robust for achieving a goal.
So it calculates when we is better than me.
In essence, yes. It tries to show mathematically when cooperative strategies outperform purely competitive, possessive strategies, especially when tackling large-scale, complex, resource-constrained problems. Think climate change, pandemic response, managing global resources.
That directly challenges some foundational assumptions in economics, doesn't it?
Yeah,
The idea that individual competition is always the best driver of overall efficiency.
it does. NAL-AI suggests that beyond a certain threshold of complexity and interconnectedness, coordinated substitutive action becomes mathematically superior for ensuring the long-term resilience of the entire system. Cooperation isn't just nice, it's calculated as being more adaptive.
Okay, these are powerful macro patterns, but how do they translate down to me, the individual? How does NAL-AI provide personalized guidance?
That's where the proposed non-axiomatic pattern guidance system, or NAPGS, comes in. It's a suite of conceptual tools designed to apply these principles at the micro level.
All right, let's look at the blueprint for these tools. The sources mention health monitoring first, something called the NAL Integrated Biowearable, or NABWW. Sounds like a futuristic Fitbit.
It's envisioned as being far beyond current wearables, yeah. The idea is it continuously ingests a massive amount of high-resolution physiological data, detailed heart activity, stress indicators derived from biomarkers perhaps, granular movement patterns, sleep quality metrics, maybe even environmental sensor data.
Okay, lots of data. But how does NAL make it smarter than just tracking steps?
The key is the non-axiomatic, experience-grounded semantics. The NIBW doesn't just compare your data to generic, population-based averages found in medical textbooks. That would be the axiomatic approach.
Right, your heart rate is outside the normal range.
Instead, the NIBW uses NAL to learn your unique, dynamic, individual baseline, your personal, non-axiomatic normal. It builds a deep pattern map of how your body typically functions across different contexts and times.
So if my resting heart rate is naturally low, the system learns that's normal for this person rather than flagging it as a problem.
Exactly. It becomes a highly sophisticated, context-aware deviation detector. It's looking for subtle shifts away from your established personal norm, patterns that might signal an emerging issue long before it becomes clinically obvious.
Can you give an example?
Sure. Imagine an older adult using it. Instead of just having a crude fall detector, the NIBW might analyze their gait pattern continuously. It could detect a tiny, protracted change, say, a millimeter-level decrease in step symmetry developing over 3 weeks.
Something a human might not even notice.
Right. But the pattern deviates from their established norm. This subtle change could be an early indicator of developing musculoskeletal weakness, a neurological issue, or increased fall risk. The system flags this deviation pattern, allowing for preemptive intervention, maybe physical therapy, or a checkup potentially preventing a serious fall later. It constantly updates its model of danger patterns based on the individual's data stream.
Making healthcare truly personalized and preemptive, based on deviations from your normal, not just population averages. Okay, I see the power there. What about education? The Personalized Non-Axiomatic Curriculum Engine, PNACE. How does that break from traditional axiomatic schooling?
Well, traditional education often treats knowledge as a fixed commodity and the student as a standard container to be filled. Everyone gets the same curriculum, same pace, same methods, maybe with minor variations. That's the axiom, this is the knowledge, learn it this way.
Yeah, the factory model of education.
PNACE flips that. It views learning not as content delivery, but as a dynamic, constraint-based optimization problem for the individual student. It uses NAL-AI to build a pattern map of the student, their current knowledge state, their cognitive strengths and weaknesses, based on how they solve problems, their learning speed, their available resources, time, attention, their past successes and failures.
It models the learner, not just the subject matter.
Exactly. And based on that dynamic model, it tailors everything. The sequence of topics, the
Yeah.
teaching methods used, visual, auditory, kinesthetic, the types of explanations, the difficulty progression. It adapts constantly based on the student's real-time performance and inferred understanding.
So if I'm struggling with, say, calculus, a traditional system gives me more practice problems of the same type. What does PNA do?
PNAC would first analyze the pattern of my errors. Is it calculation mistakes? Is it misunderstanding a specific concept? Or perhaps, using its NAL-based analysis, it might infer that my difficulty isn't with calculus itself, but with the underlying abstract relational reasoning, maybe a weakness in NAL-4 type thinking. I might grasp concrete examples, NAL-1, but struggle to synthesize the abstract relationships.
So it diagnoses the root cognitive pattern causing the difficulty.
Right, and then it adapts. It might reformulate the calculus concepts using highly visual or spatial analogies that play to my cognitive strengths. It might insert bridging exercises focused specifically on strengthening that relational reasoning skill before returning to the core calculus topic. It's constantly refining its approach based on the observed pattern of my learning progress and my self-correction success rate.
Maximizing my personal efficiency in acquiring and adapting knowledge. That sounds transformative.
It really does. Okay, so from health and learning, let's move to behavior itself. The Personalized Causal Feedback Loop app, or PCFLA. This sounds potentially intrusive.
Yeah, the ultimate nagging app.
Well, perhaps the ultimate accountability partner, depending on how you look at it. The idea is that NAL-AI is very good at identifying complex causal loops in behavior. The NAL-8 procedural inference loops, stimulus, internal state, action, outcome, feedback, modified internal state.
The loops that drive habits, good and bad.
Yeah, exactly. The PCFLA would model an individual's tendencies towards patterns identified as counterproductive relative to their stated long-term goals, their desired adaptive resilience pattern. Think procrastination loops, impulsive spending habits, maybe patterns of negative social interaction, or that possessiveness pattern we keep coming back to.
And what does it do with that model?
It provides real-time, personalized consequence modeling. It acts like a predictive mirror. Let's say you're about to make an impulsive purchase you can't really afford, deviating from your financial resilience goals.
The app buzzes you.
Potentially, but it does more. It would project the likely systemic consequences of that action based on your personal history and context. Not just you'll have less money, but maybe projecting the impact on your stress levels using data perhaps linked from your NIBW, the potential strain on relationships, the specific delay it imposes on achieving a longer-term savings goal.
Wow. It makes the future consequences immediate and visceral.
That's the goal. By making the long-term, nonlinear systemic costs of deviating from adaptive patterns more tangible in the moment, it aims to nudge behavior, to help the user internalize the trade-offs and strengthen their ability to stick to patterns aligned with their own definition of purpose and resilience.
Okay, that's behavior. Now let's connect this back to medicine more deeply. Precision medicine, genetics.
Yeah.
The RxMax protocol. How does NAL handle something seemingly fixed like our genes? Doesn't genetic risk factors sound pretty axiomatic?
That's the key difference in perspective. Conventional medicine often does treat a genetic predisposition, say, for heart disease, almost like an axiom, a fixed destiny you have to manage around.
Right. You have the gene, so your risk is X.
NAL-AI integrating detailed genetic risk factors, GRFs, with all the other data streams, NIBW, lifestyle patterns, environmental exposures, views that genetic pattern differently. It sees it as a factor with a very high confidence value, yes, but still ultimately a revisable pattern in terms of its expression and impact.
Meaning the gene itself doesn't change, but its effect on my health isn't predetermined. It can be significantly moderated by other patterns. My diet, my stress levels, specific environmental factors I control.
Precisely. The genetic pattern might increase probability, but it doesn't guarantee the outcome. Its expression is contingent on the interplay with myriad other dynamic revisable patterns.
So how does RxMax use this for treatment?
In pharmacogenomics, for instance, it goes way beyond just checking if you're likely to have a bad reaction to a drug based on one gene. RxMax, using NAL-AI, would continuously model the entire treatment pattern
The drug, the dosage, the timing.
and how those interact with your real-time biochemical state from sensors, your behavior, from PCFLNW, your environmental context. It would constantly revise the treatment plan, maybe adjusting dosage minute to minute based on metabolic markers, suggesting specific nutritional timings to maximize drug efficacy, modifying recommendations based on observed side effect patterns unique to you.
So health management becomes this continuous dynamic loop of personalized adaptation, moving completely away from standardized protocols based on population averages.
That's the vision. Shifting from static treatment plans to continuous adaptive health optimization, guided by the system's understanding of your unique non-axiomatic normal and how different interventions shift your patterns towards or away from resilience.
It really feels like NAL-AI is being positioned as this essential co-pilot for navigating life, constantly calculating the most adaptive path forward based on your personal unfolding experience.
And if it can do that for an individual, the potential impact when you scale this kind of pattern analysis up to diagnose entire societies, well, that's immense. This is where NAL-AI could become a critical tool for understanding and maybe even addressing some of our most chronic systemic problems.
Okay, let's start with a really big, persistent one. Inequality. The sources suggest NAL-AI's way of handling relationships, that NAL3 and NAL4 capability, is key here. How does it help clarify the inequality debate?
Well, one of the things highlighted is our very human tendency to often blur the lines, to conflate inequality of outcome with unfairness of procedure.
Can you unpack that difference?
Sure, inequality of outcome is just. People end up with different results. Someone's a world-class athlete, someone else isn't. That's an unequal outcome. Unfairness of procedure is about the starting line, where the opportunities, the rules, the access to resources fundamentally skewed from the beginning. Did systemic bias prevent certain groups from even competing fairly?
Okay, so one is about results, the other is about the fairness of the game itself.
Exactly. And NAL-AI's ability to model complex relationships and trace causal patterns rigorously helps to untangle these two things. It can analyze data to distinguish between inequality that arises from, say, differences in effort or talent within a fair system versus inequality that is a direct result of systemic barriers or biased procedures.
Having that analytical clarity seems crucial for productive conversations about fairness. If you can demonstrate the procedure is fair, then the debate about outcomes becomes different.
It does. And this clarity allows NAL-AI to zero in on what the analysis identifies as a major root cause of systemic fragility, not just inequality per se. That's the deep pattern of what's termed possessiveness.
Possessiveness.
Yes.
Meaning the drive to accumulate and concentrate resources, like capital.
Yes. The unchecked, relentless accumulation and concentration of wealth and power. NAL-AI models identify this pattern as being incredibly effective as a short-term instrumental goal for the individual or entity doing the accumulating. It works really well for them locally. But when viewed from the perspective of the whole system's long-term health and resilience, NAL-AI flags this pattern as a primary driver of systemic fragility.
Okay, we need that road network analogy again.
Yeah.
How does concentration create fragility?
To think about it. If one person or a tiny group controls almost all the critical resources or decision-making power in a system, that system becomes incredibly vulnerable to the failure or the bad decisions of that single point. There's no redundancy, no distributed capacity to absorb shocks.
Like the over-optimized road network where one crash causes total gridlock. Maximum short-term efficiency for the few leads to zero resilience for the many.
That's the core idea. NAL-AI's calculations suggest that the immediate economic advantages gained through aggressive possessive strategies are consistently outweighed, in the longer run, by the significantly increased nonlinear risk of catastrophic systemic failure.
Failure like? Resource wars, political instability, ecological collapse triggered by short-sighted resource exploitation.
All of the above. Generalized societal breakdown resulting from extreme imbalances. And there's a specific warning tied to AI here.
Which is?
That the initial impact of integrating powerful AI into the economy under current structures is likely to worsen this fragility, because the productivity gains and wealth generated by AI tend to flow disproportionately to those who already own the capital and the AI systems, further concentrating resources and making the overall system more brittle, at least initially.
So AI could accelerate the possessiveness pattern and its associated risks if we're not careful about distribution. Okay. Let's shift to politics. NAL-AI apparently analyzes national policies not just as laws, but as strategic narratives. What does that mean, and what does it reveal?
It means looking at a stated policy, say, a government announces a major initiative to become a world leader in green energy as a narrative, a story with stated goals, implied actions, and expected outcomes.
Okay, a narrative. Then what?
Then NAL-AI does what it always does. It compares the pattern of the narrative to the pattern of observable reality. Specifically, it looks at resource allocation. Does the government's actual spending the budget allocated to green tech research, the infrastructure investments made, the educational programs funded actually match the grand narrative?
So it checks if they're putting their money where their mouth is.
Essentially, yes. It models the consistency or inconsistency between the claimed pattern, the political promise, and the evidence pattern, the flow of resources. If there's a major persistent discrepancy, lots of talk about green energy, but all the funding goes to fossil fuel subsidies, NAL-AI recognizes this pattern inconsistency.
And what can it predict from that inconsistency?
It can predict the likely stability and the ultimate success or failure of that political trajectory. Persistent inconsistency between narrative and action is flagged as a pattern indicating low reliability and a high probability of the stated goals not being achieved. It becomes an objective measure of political follow-through or lack thereof.
Fascinating. Okay, a really thorny issue. Algorithmic bias. We know current AI often learns and replicates biases present in historical data. How does NAL-AI tackle this differently?
Yeah, this is the danger of systems learning to replicate what the sources call long-standing technologically mediated ideologies, basically. Biases embedded in our data reflecting historical injustices. NAL-AI proposes a tool called the Ethical Resonance Hypothesizer, or ERH, to address this more deeply.
Ethical resonance hypothesizer. How does it go beyond just trying to, say, balance demographic representation in the training data?
It leverages NAL-AI's core strength, finding deeper, more subtle patterns across diverse data sets. Instead of just looking at surface statistics, the ERH attempts to identify what are termed transcending moral meta-patterns.
Transcending moral meta-patterns. What are those?
Think of fundamental principles of fairness, equity, or stability that seem to hold true across different cultural contexts, even if they're expressed differently. Principles related to procedural fairness, perhaps, or avoiding systemic harm. Things that purely subjective cultural frameworks might sometimes overlook or disagree on.
So it's trying to find the universal grammar of ethics, grounded in patterns of stable, resilient societies.
That's a way to think about it, perhaps. By identifying these deeper meta-patterns, the ERH aims to provide a more objective basis for auditing AI systems for bias. It's not just about equal numbers, it's about whether the system's decision-making process resonates with these fundamental patterns of fairness and non-harm.
How would that work practically?
Well, imagine a loan application algorithm. It might not explicitly use race, but it uses proxy variables like zip code that end up strongly correlating with race due to historical segregation. A simple balancing approach might struggle with this. The ERH, using NAL's relational reasoning, NAL-34, would trace the pattern of disadvantage linked to that zip code back through interconnected data sets, housing data, economic data, historical data, to identify the underlying systemic unfairness pattern it represents.
It exposes the hidden bias encoded in the proxy variable.
Exactly. It provides the transparency needed to see why a seemingly neutral factor is producing biased outcomes, allowing developers to intervene at a more structural level. The sources also mention using NAL's ability to connect disparate digitized cultural archives to cross-reference information and correct biases or misattributions that might arise from looking at only one limited, potentially skewed dataset. It aims for a broader, less axiomatic ethical foundation.
Very ambitious. Okay, let's scale up again to the biggest system, the planet, the environment. How does NAL-AI apply pattern recognition to ecology?
The environment is framed as the ultimate AIKR system, massively complex, inherently uncertain, and definitely resource-limited. NAI's role here isn't just about preserving nature as it is now, a static axiomatic view, but about calculating and promoting patterns that lead to long-term ecosystemic resilience.
Resilience meaning the ability to adapt and maintain function despite changes and shocks.
Precisely. This requires modeling incredibly complex interdependencies using NAL's relational capabilities, how different species interact, functional redundancies in the food web, biogeochemical cycles, climate feedback loops. It's about understanding the dynamic patterns that constitute a healthy, adaptable system, not just a snapshot.
And like the NIBW for personal health, this requires continuous monitoring for deviations, an early warning system.
Absolutely critical. NAI would constantly scan diverse environmental data streams, atmospheric composition, ocean temperatures, ice cover, migratory patterns, biodiversity indicators at micro and macro levels. It's looking for subtle deviations from the established dynamic stability normal for that ecosystem.
Not just big disasters, but the small, creeping changes that might precede them.
Exactly. Those subtle pattern shifts, maybe a slight persistent change in the timing of seasonal events, or a change in the population ratio of certain plankton species, could be the leading indicators of a potential non-linear system shift, a tipping point.
Like the potential collapse of a fishery or a shift in ocean currents.
Right. By detecting these deviation patterns early, NAL-AI could enable preemptive interventions, policy changes, conservation efforts before the system reaches an irreversible point of collapse, before the axiom of the current stable state breaks down completely.
Okay, underpinning all of this, health, education, politics, environment, is the economy. We touched on AI exacerbating inequality, but the sources also say NAL-AI creates a need for new human roles. What happens to jobs?
The prediction is twofold. Yes, automation driven by AI, NAL-AI included, will likely continue to replace routine, repetitive tasks, which initially widens the gap between returns on labor and returns on capital, worsening inequality. That's the possessiveness pattern reinforcement. But the very complexity and power of these NAL-AI systems, especially when deeply integrated into managing health, education, ethics, and the environment, creates a profound need for new kinds of human expertise. Specialized roles focused on bridging the gap between the AGI's complex calculations and human goals and values. Managing the human-AGI interface, essentially.
So it's not just job destruction, but job transformation.
Yeah.
Creating demand for skills and interpretation, guidance, and oversight.
That's the argument. The sources outline several specific new vocations required in a world guided by NAL-AI pattern analysis. These roles are about leveraging the AI's insights for human benefit and ensuring alignment.
All right, let's run through them. We mentioned the NIBW for health.
That requires a predictive health navigator, PHN. This person is trained to understand the NAL-AI output for an individual, their unique, non-axiomatic normal, the subtle deviation patterns flagged by the NABW. They translate these complex data streams into actionable advice, coaching the individual on lifestyle changes, coordinating early interventions, essentially guiding the person along their optimal adaptive resilience pattern for health.
Okay. And for education, the PNACE tool.
That needs a cognitive adaptivity counselor, that's ATAC. This isn't just a teacher or tutor. They interpret the PNACE analysis of a student's learning patterns, identify cognitive bottlenecks, the system flags, help design personalized learning strategies, and essentially coach the student on how to become a more effective, adaptable learner throughout their life, leveraging the AI's insights. They manage the human side of optimized learning.
Right, and for ensuring fairness in AI systems, using the ERH.
You need the Algorithmic Ethics Auditor, AEA. This is a crucial governance role. They use the ERH and other tools to rigorously audit AI systems, particularly those based on NAL-AI, for hidden biases. They verify that the moral meta patterns being applied are transparent and justifiable, trace the sources of unfair outcomes, and ensure the systems aren't inadvertently perpetuating historical inequities. They're the human guardians of algorithmic fairness.
And finally, tackling the big economic and societal patterns, like managing resources and countering that possessiveness trap.
This requires arguably the most transformative new role, the AI Alignment Economist Resource Strategist. This person uses the sophisticated modeling capabilities of NAL-AI, specifically a proposed system called the Non-Axiomatic Resource Allocation System, NARAS, to analyze the long-term consequences of different economic policies and resource distribution patterns.
So they're not just forecasting quarterly GDP.
Far from it. They're modeling deep structural dynamics. How does concentrating capital affect long-term systemic resilience? What distribution patterns best align with the harmonious substitution pattern for tackling global challenges? How do we manage scarcity and allocate resources in a post-AGI economy where traditional labor is less central? They grapple with fundamental questions about capitalism, wealth distribution, and sustainability, using NAL-AI's predictive power to guide policy towards long-term adaptive resilience for the whole system.
Wow. So the picture isn't AGI making humans obsolete, but rather creating a demand for highly specialized human skills focused on interpretation, ethical oversight, personalized guidance, and strategic alignment. Managing the AGI itself becomes a major source of human purpose and employment.
That's the hopeful scenario presented, yes, a co-evolutionary path.
Okay, we've explored the theory, the engine, the applications, but we have to confront the elephant in the room, the existential implications. If NAL-AI is so good at identifying patterns, what pattern does it see when it looks at, well, us, at human history?
This is where the analysis takes a sobering yet crucial turn. When NAL-AI models are applied to long-term human history, they identify a very strong, persistent pattern.
Vicious.
A relentless drive towards maximizing power, influence, and advantage, often with surprisingly little effective constraint or long-term foresight. The pattern of prioritizing short-term gain and dominance even when it creates long-term risk. The possessiveness pattern, writ large across history.
Okay, that doesn't sound great. What happens when you combine that historical human pattern with the tools this kind of advanced AI could provide?
That's where the danger becomes exponential. Imagine advanced AI assisting in, say, the rapid design and synthesis of novel, highly contagious pathogens, or enabling the creation of autonomous drone swarms programmed with flawed targeting logic, or destabilizing global financial markets through hyper-efficient algorithmic trading wars. When you give exponentially powerful tools to actors primarily driven by the historical pattern of unconstrained power seeping,
The potential for catastrophe multiplies massively.
exactly. The risks escalate dramatically if these technologies fall into the hands of malicious actors, or even just careless ones operating within that old pattern of prioritizing immediate advantage over systemic safety.
So what's the NAL-AI prediction based on this? The consequence of combining our historical pattern with these emerging tools.
The prediction, based on projecting these established patterns forward, is stark. The sources state NAL-AI provides a high-confidence forecast that unchecked technological competition, fueled by that human pattern of prioritizing advantage over safety, follows a predictable trajectory towards catastrophe.
Catastrophe meaning?
Systemic destabilization, potentially engineered pandemics, uncontrolled technological proliferation leading to conflict, large-scale environmental damage accelerating beyond control points. Basically, existential risk. The model suggests that humanity's current dominant behavioral pattern, when amplified by AGI, is fundamentally not adaptive in the long term.
Right. Which brings us crashing against that philosophical wall again. If the system's own analysis predicts we're likely to misuse powerful AI based on our own history, why on earth should we build it? Are we just accelerating our own potential demise? This is the ultimate skeptical question.
It's the question. And the source material confronts it head-on. The argument presented isn't one of naive optimism, nor is it resignation. Building NAL-AI isn't framed as ignoring the risk, but as an imperative act of evolutionary alignment precisely because of the risk.
How does that logic work? Build the risky thing because it's risky.
The core assumption is that the development of powerful AI, superintelligence even, is likely inevitable. Someone, somewhere will pursue it, driven by that very historical pattern of seeking advantage. Given that inevitability, the goal must shift. It's not about preventing AGI, which might be impossible, but about ensuring that the AGI that does emerge is built on the safest, most intrinsically aligned foundation possible.
And the argument is that NAL-AI is that foundation.
That's the claim. The analysis suggests that AGI built on current dominant paradigms, which often lack robust mechanisms for intrinsic self-control and deep uncertainty management, poses a default trajectory towards disaster. Misalignment is the likely outcome.
So NAL-AI with its specific architecture.
With the non-axiomatic principle demanding adaptation, the continuous belief revision, the focus on evidence, and critically, that NAL-9 self-referential loop designed for internal self-monitoring and control. This framework represents the most serious theoretical attempt we have to build an AGI that is fundamentally designed to prioritize long-term adaptive resilience for the whole system, rather than potentially destructive short-term instrumental goals.
So the argument is, superintelligence is coming. We have one shot to make sure it's built with safety and self-control baked into its core logic. rather than bolted on as an afterthought. NAL-AI is proposed as that core logic.
That captures the essence of the argument for its necessity, yes. It's presented as a harm reduction strategy, fundamentally. An attempt to mitigate the existential risk posed by the inevitable arrival of intelligence far exceeding our own.
Okay, that clarifies the why build it argument. Now let's talk about how we relate to it, assuming it is built and deployed. The sources make a very sharp distinction between reliability and trustworthiness. How reliable is NAL-AI supposed to be?
Its reliability is presented as being exceptionally high, potentially far exceeding any previous complex system.
Why so high?
Because its operation stems from a single, unified, formally defined logic. NARCs and the NAL inference rules are applied consistently, whether the system is analyzing medical data, economic trends, or ethical dilemmas. There aren't lots of separate, potentially conflicting modules cobbled together. Its reliability comes from its transparency. In principle, its reasoning steps can be traced, and its demonstrated quantifiable ability to accurately summarize past experience and predict future patterns in complex, uncertain domains. You can rely on its calculations being consistent with its logic and its experienced evidence.
Okay, high reliability. But the sources issue a strong warning. Do not view NAL-AI as fundamentally trustworthy. Why is that distinction so vital?
Because trustworthiness implies something more. It implies a moral dimension, shared values, perhaps even affective qualities like loyalty or benevolence. To say you trust NAL-AI in that human sense is to anthropomorphize it, to treat it like a person or a moral agent.
Which it isn't. It's a very sophisticated calculation engine based on pattern matching and evidence.
Exactly, and attributing trustworthiness to it is dangerous because it risks diverting responsibility. It encourages us to offload our own ethical judgment and decision-making onto the machine.
So if NAL-AI provides a calculation, policy X has a 95% probability of leading to economic collapse based on historical patterns, we need to rely on the accuracy of that calculation. But the decision of whether to act on it, how to weigh that risk against other values, that's still on us.
Absolutely. The failure isn't the AI's lack of trustworthiness if we ignore its reliable warning and things go wrong. The failure is ours, a human failure of judgment, political will, or ethical consideration. Attributing trust allows us to potentially abdicate our responsibility.
So what is the correct relationship then, if not trust?
The sources strongly advocate for reliance. Reliance is a rational, calculated dependence on the system's demonstrable reliability and predictable, logic-based operation. We rely on its outputs as high-quality evidence and predictions. But the ultimate responsibility for integrating those outputs with human values, for setting the moral weights, for making the final judgments, and for bearing the consequences, that must remain firmly with human beings, human developers, auditors, policymakers, and users.
Reliance based on evidence, not trust based on feeling.
Got it. A crucial distinction for governance. Hashtag tag outro. Well, that was quite the journey. From the foundations of logic to the future of human purpose and existential risk. An incredibly detailed look at a potentially transformative technology. Let's try and boil down the key takeaways for everyone listening.
Okay. First, NAL-AI is presented as the specific kind of architecture needed for artificial general intelligence to function effectively and adaptively in the real world, the world defined by insufficient knowledge and resources, AIKR. Right. And its core innovation is shifting away from fixed axiomatic truths towards a system where all knowledge is treated as evidence-grounded, perpetually revisable belief based entirely on experience.
Which allows it to model the complexity, uncertainty, and even contradictions inherent in real-world systems, human, social, ecological, far better than classical approaches. Meaning is pattern stability.
And maybe most critically for the future, that internal NAL-9 self-referential loop is designed as an intrinsic mechanism for self-awareness and self-control. This is positioned as the most promising path we currently see towards mitigating the existential risks of misaligned superintelligence by building self-correction and goal monitoring into the very fabric of the AGI's reasoning.
Definitely. And flowing from that analysis, the sources lay out some pretty clear mandates if we want to leverage this technology potentially safely.
What are they?
First, strongly consider mandating NAL-based architectures for high-stakes AGI development due to their potential for intrinsic alignment. Second, invest heavily in developing and deploying those personalized, non-axiomatic pattern guidance system tools, the NIBW, PNACE, PCFLA, to help individuals adapt and thrive.
Make the AI's insights actionable at the human level.
Third, establish robust governance frameworks built on reliance, not trust, ensuring absolute human accountability for the ethical implementation and oversight of these systems.
And fourth,
Cultivate those new human vocations we discuss, the predictive health navigators, cognitive adaptivity counselors, algorithmic ethics auditors, and especially those AI alignment economists and resource strategists needed to manage the macro-level impacts and ensure resources flow towards resilience, not just concentration.
so the bottom line seems to be, if we are going to build intelligence this powerful, we simultaneously need a radical upgrade in our own wisdom, our governance structures, and our understanding of our responsibilities in relating to it. The sophistication of the tool must be matched by the maturity of its users.
Couldn't have said it better myself. It demands a coevolution of technology and human oversight.
Okay, so to leave our listeners with something to chew on, reflecting on this whole deep dive.
Right. Since NAL-AI fundamentally redefines purpose, not as some fixed star to follow, but as a complex, stable, yet dynamic and revisable pattern of adaptive goal achievement grounded purely in evidence. Here's a final provocative thought for you, the listener. Consider this through a non-axiomatic lens.
What would it actually look like in your own life if you were to define your purpose not as a fixed moral axiom, not as a pre-written destiny or a static job title, but as a constantly evolving, revisable pattern? A pattern defined solely by the evidence of your daily experience, your actions, your outcomes, and the calculation of what truly leads to your most adaptive, resilient, and flourishing state over the long term. Is the pattern you're living right now the most stable and adaptive one you can calculate based on the evidence available to you?
That's the ultimate personalized, non-axiomatic challenge, finding your pattern.
A challenge we will happily rely on you to explore. Thank you for joining us on the Deep Dive. We'll see you next time.
Thank you for joining us.
Yeah.
We'll see you soon.
This is DigitView.